students, welcome to the Data Structures and Algorithm lecture series. In today's lecture, we are going to understand the new concept that is a binary tree traversal techniques. Now, before we understand the binary tree and its traversal techniques, we'll first see that tree is really very good data structure, one of the important data structure we can say. A tree sometimes look like this, okay? So what is a binary tree exactly? So binary tree is explained by these lines. In a binary tree, the topmost element is called as the root node. So we see the topmost node over here, this can be called as a root node. Each node has 0, 1 or at most 2 children. As the name says binary, that means 2, a node can have 2 children. So maximum 2 children means minimum 0 children. Okay. So there is a node, yes, this is having 0 children, it's allowed. There is a node which is having 2 children, it is allowed. But here if you see this particular node is having 3 different children, so it is not allowed. Okay, so a node can have 0, 1 or 2 children at the max. Yeah, a node that has 0 children is also called as a leaf node or a terminal node. Okay, so here the node which has 0 children, here we can see these are the nodes which are having 0 children, so they are also called as the terminal nodes. Other than the terminal, these internal nodes are called as the non-terminal nodes. Okay, so every node contains a data element. Each node has some value or data assigned to it. There will be a left pointer which is pointing to the left child and a right pointer which is pointing to the right child. Okay, so and then the root element is pointed by the root pointer. So root of the tree is always maintained by a variable. You can give a name as a root. Initially, if the root is null, that means the tree is empty. So when we begin with the tree, we initialize the root as null, that is the tree is empty, and when we get some values to add, we add those values and we generate a tree. Okay, so this is all about binary tree. Now we'll go and understand the different traversals that we use to traverse through the binary tree. Suppose if I have a binary tree, I want to read all the values in my binary tree. So it is not that easy as I go with a linked list or with the array. Yeah, I just start from the beginning and I just go in a one direction and I can get all the items in a sequence, because here it is a non-linear type of a data structure where we don't have a particular sequence in which the data items are there. Okay, so to read something from the tree, okay, I have to use some of the traversal techniques, and this traversal techniques, there are 3 different types of traversal techniques with the binary tree. Those are Inorder, Preorder and Postorder. Okay, so when I say Inorder, it means LVR. L stands for left, R stands for right, and V stands for the vertex node that we are talking about, in which the data item is there. We want to read the data item. Okay, preorder VLR, okay, and postorder LRV. So here V is in between, okay, that's why the name in, because V is in between L and R. Pre because V is prior to L and R. Postorder because V is post or after the L and R. So that's the name suggests. The same way we have this notations for Inorder, Preorder and Postorder. Okay, these are the 3 types in which I can display the nodes in my tree. I can traverse through my tree. Okay, so now let's see the first type of traversal technique. This is the first technique, that is Preorder Traversal techniques. With this particular technique, we will be able to read the items in a binary tree. Okay, so this traversal techniques, as you can see the diagram, there is A is going to B and C. That means A is a node which has 2 children, B as a left child and C as a right child. Okay, then the algorithm to read the items in Preorder Traversal says visit the root node. That means I should be visiting the root node first. Okay, say for example I have visited A, that means I am reading A. Then traverse to the left subtree, go to the left of A, okay, and here once I visit this particular node, again over here I have to follow this algorithm from beginning to end. That means visit the root node. So here the visiting the root node is B. Then I have to traverse to the left. So there is nothing on left of B. So I'm coming back. Then it says statement 3 is traverse to the right subtree. There is nothing on right of B. Again I come back. So I have to go back onto parent node. Once I reach the parent node, at A we had done this and we had done this, but this third line was remaining. So we'll execute the third line, that is traverse to the right subtree. Now I will go to the right subtree and I reach the node C. At node C, again I start my algorithm and the statement 1 says visit the root node. So I visited C. That means I write C. Then it says go to the left subtree. There is nothing on the left, so I come back and go to the right subtree. There is nothing on the right. Again I come back. Then I have to go back to the parent. At A also we have finished all the 3 lines of the algorithm, and so here we stop. So at the end what I read from my tree is A, B, C. So if I read a tree in pre-order sequence, it will be giving me answer as A, B and C. As you can see, the output is A, B, C. Okay, that's why we call, as you can see over here, this is visiting for V root node. Then go to the left subtree is L and go to the right subtree is R. So the pre-order notation is VLR. Okay, if you have understood this, let's try to solve this particular example and find out the pre-order traversal for the given tree. Now this is one of the binary tree, yes, because every node has either 0, 1 or 2 child. Yeah. So now I can find out the traversal, or I can read this tree using pre-order traversal technique. So as we all know, what is the notation that we use for pre-order traversal? That is VLR. Okay. So here I will be using this VLR notation for all the nodes. Okay, when you are solving it, you can just do this marking with a pencil. Okay, if you are doing it for exam point of view. Okay, now what I've done is I wanted to find out the pre-order sequence. That's why I have written VLR on every node. Okay, now what I'm doing is I will start from the root node. Who is my root node? A. Okay, so I'll start from A. Okay, so we start from a root node. Now what I'm doing is, okay, I will first visit read the lines at A. Okay, so what are the lines at A? VLR. So I'll go to the V, that is visit node A. Okay, so that means I have to, whenever V comes, I have to read that node. Yeah, so I'm reading A. Then it says go to L. So I'm cutting down the L line and I'm going to the left child. So left child is B. At B, I have to first visit node. That's why I write B. Again, I go to the left child. So I go to D. At D, I have to visit the node. That means I'm reading D. It says go to the left child. So DK left me, I have H. So I go to H. H says visit the node. That's why I read the node H. Then after that, H says go to left child. There is no left child of H, so we are coming back. Then it says go to right. There is no right child of H. Again we are coming back. After finishing all these values in H, what I'm supposed to do is go back to my parent. So H, we are going to back to D, that is parent of H. Now here what is remaining is R. So go to R. Then we are going to the right child, that is I. I'm visiting the I, that means I'm writing I. Then it says go to the left child. There is no left child for I. Go to the right child. No right child for I. As I have done with all the values of I, I'm going back to my parent, that is D. At D also, we have finished all at D. Now we are going back to the parent of D. So we are going to B. At B, I have only remaining thing is R. So I'll visit R. That means I go to the right child, that is E. At E, I have to first visit the node. That means I will write down E. Then go to the left child. So I'm going to the left, that is J. At J, I have to visit the node. That means I will write down J. Then it says go to the left child. There is no left child. Go to the right child. There is no right child. I am done with all. So I will go back to my parent. At E, it says go to right, but there is no right child. So I'm done with all the 3 operations. I go back to my parent. So at B we return, but at B also all are done. So I will go back to parent. So that means I'm reaching A. At A I have already done V and L, but R is remaining. So I will just do R and I'm going to the right child, that is C. At C what I'm doing is first visit the node. So I will read C. Then go to the left of C, that is I'll go to F. At F I will visit the node, that means I'll write down F. At F, you go to the left, there is no left child, so we come back. Again, you go to right, there is no right child of F, you come back. You're done with all the operations at F, so you come back to its parent, that is C. At C, only R is remaining, so we go to the right child, that is G. G says first visit the node, so I will write down G. Then it goes to the left child, so at left I have K. K says you visit the node. Okay, so I go to, I write down K over here after visiting the node. Go to left, there is no left child. Go to right, there is no right child. Okay, so once I'm done with all, I have to go back to the parent. So I reach G now. G says go to right, but there is no right child. Okay, so I'm done with G also. I go back to the parent. At C also we are done all. So we go back to the parent. At A also we are done all. So when we are done all the operations at root node, that is at A, we will stop the traversing technique over here. So when we stop, what do we get is, we get the final answer, and this particular answer having all the nodes of your tree visited in pre-order traversal sequence. So this is the final answer, that is A, B, D, H, I, E, J, C, F, G, K. I hope you understood this pre-order traversal technique. Now let's go ahead and understand the next traversal technique. So next is in-order traversal technique. As its name suggests, in order, if we have given this particular ABC over here, we can just see that we first traverse the left subtree. That means I will first go to the left, I will read B. Then I go up and visit the root node, that means I have to visit the A. Then I have to go to the right child and visit the right node, that is C. Okay, so here the left is coming first, then visiting the root node, then right side. That's why the name suggests in-order says it uses LVR notation and the output for the given tree will be BAC. Now let's understand this in-order traversal with the same example, that is LVR notation. Now this is a tree given to us. I want to read this tree using in-order sequence. So how I will go ahead with that? Okay, so I know for in-order I have to write V in between L and R. So I will first do that. I will write LVR for all the nodes. Now I will start with the in-order traversal sequence. So here we start with the root node first. So here it says first go to the left child. That means I am not printing A, I am just going to the left. Here I reach B. B says go to the left. Again it says go to the left. At D it says go to left. So I am going to H. H says go to left. There is nothing on left. So we come back and now I have to execute V. So V says okay, read H. Whenever we say V, we will read that value. So read H. Then after reading H, it says go to right. There is nothing on right of H. Again we come back. So now I am done with all the 3 operations here. So I come back to the parent of H, that is D. Now D has saying that visit the node D. So that time I should be writing the value of D node. Then go to the right child. So now I am at right child, that is at I. I says go to the left first, but there is nothing on the left. So we come back over here. Okay, and now it visit the node I. So I will write down visit I. Then it says go to the right child, but there is nothing on the right of I. So I'm done with I. I will go back to the parent. Now who is the parent? D. At D again we have done all the operations. So we go back to the parent. Who is the parent? B. B says visit node. So now I will be visiting the node B. Then it says go to the right child. So now I'm going to the right of B, and that is E. E says go to the left, so I'm going to J. J says go to left, but nothing on left. Then it says visit the node J. Okay, so I will visit the node J. After reading J, what it says me? Okay, after visiting J, it says go to the right. Okay, so I'm going on right. So there is nothing on right. So I'm done with the J. So I go back to the parent, that is on E. Now I go back to E. At E, I'm visiting the node E. So I'm writing E over here. Then I'm going to right of E, but there is nothing on right. So I will just come back. Now I'm done with all the operations at E. So I go to the parent of E, that is at B. B has also finished with all the operations. So B will go to its parent, that is A. Now A says, okay, now you visit the node. So I will write down A over here. Okay. After that, A says go to the right. So on right of A, we have C. C says, okay, first you go to the left. So I will go to the left of C, that is at F. F says go to left. Okay, but there is nothing on left. So I come back. Now F says visit the node. So I will write down F. Now it says go to the right of F. Again, there is nothing on right. I'm done with all the operations at F. So I come back to its parent C. C now says me, okay, now you read the value. Visit the node C. So I visit the node C. I write down the value. Now it says go to the right side. Okay, so I go to the right of C, that is at G. G says go to the left. So I go to the left, that is at K. K says go to left, but nothing on left. Then K says visit node K. So here I write down K. Okay. After visiting, it says go to the right, but there is nothing on right. So I'm done with all the operations at K. I go to the parent of K, that is at G. G says go to visit the node. So now I will visit the node G. Now G says go to right, but nothing on right. So we are done with all operations. We come back to the parent. At C also we are done all the operations. We go to the parent of C. Now we are reaching A, but A also we are done with all the operations. So we will stop here because we have reached the root node and we are done with all the operations. Now we can see the sequence in which we have read the values is the Inorder Traversal sequence for the given diagram. Okay, that is H, D, I, B, J, E, F, C, K, G. Okay, so this is the final answer for Inorder Traversal sequence. Now let's go understand the next traversal sequence, that is a post-order traversal. This is third and the last traversal technique. What happens in post-order is we first traverse to the left subtree, then we go to the right subtree, and finally we visit the root node, or we write down the value of the root node, that is LRV notation. So here we'll go to the left, that is B, then C, and finally A. So output will be B, C, A. Okay, now this is all about post-order traversal. Let's understand this with the example. So again the same tree, I want to find out the post-order traversal for this tree. So I will write down the notation, that is LRV. Okay, I'll write it down for all the nodes. Now I'm starting again from my root node. Yeah, so I'm starting from the root node. It says go to left. Okay, I'm reaching B. Now it says go to left. I'm reaching D. Now again it says go to left. I'm reaching H. It says go to left. Nothing on left. So I come back. Now H says go to right. But nothing on right. So I come back. Now H says visit the node. So that time I write down the value H. After done with H, what I'm doing is I'm going to the parent of H. Okay. So at D, it says go to right. Now I'll go to the right of D. Here I found I. I says left and right, but nothing on left and right. Then I visit the node I and I write down the value I over here. After done with the I go to the parent. Now D says, okay, now you visit the node. So now I visit the node and I write down D there. I'm done with all the operations at D. I'm going back to B. At B, it says go to the right. So I'm going to E. E says go to left. So I'm going to J. J के left and right में कुछ भी नहीं है. Now I will visit the node J. After done with J, I go back to E. E says you go to right, but nothing on right. So then it says visit the node E. So now I am visiting the node E. After done with E, I'm going back to B. B says, okay, now you visit B. So now I visited B. I'm done with all the operations, then I go back to my parent. I'm reaching A, but A says go to the right. So I'll go to the right of A, that is C. C says go to left. So I'm going to left, I have F. It says go to left and right, but there is nothing on left and right. Then it says visit the node F. So again I visit the node F. Now I'm done with the F, so I go to C. Okay, and C. Okay, now C says go to the right child. So right of C is G. G says go to left, so I go to K. K says go to left but nothing on left. Again go to right but nothing on right. So then it says you visit the node K. So now I visited node K. Then I go back to G. G says go to right but nothing on right. Then G says visit the node. So I visit the node G. After G, I'm done. So I go back to my parent, that is C. C says visit the node. So now I visit the node C. I'm done with all operations at C. So I go back to my parent A. A says visit the node. So here we are visiting the node A at the last. And now I'm done with all the operations at root node. So I will stop my traversing sequence over here. So with this, we have to find out the post-order traversal sequence for the given particular tree. Okay, so here the sequence is H, I, D, J, E, B, F, K, G, C, A. We can observe that root node is coming at the end. Okay, so this is all about all the three traversal techniques, how we can get the answers. Okay, so now we will understand the next type of a question which is likely to be asked in exams, and next type of a thing which is also based on the same traversal techniques. This is one of the type of a question. So let's understand to solve this and understand the working of this. Now there is a binary tree for which the binary tree is already there, for which Inorder traversal sequence and post-order traversal sequence is given to us. Our job is to generate the same binary tree again using these two sequences. Okay, so creation of binary trees from traversal of binary trees. So I have given these two traversal. Using them, I will be generating the same binary tree. So after generating the entire binary tree, if I find out the in-order and post-order, I should get exactly the same answer. Okay, so now let's understand this. So here, what I'm going to do is, first of all, I will use some basic logics. Yeah, so as you can say, in order means something that is L, V, R. Post order is L, R, V. So it is very difficult for me to say, looking at this, which node is at left, which node is at right, how many at left, how many at right. Okay, it's very confusing. But how many root node? It's very simple. Root node is only one. Yeah. So in order में root node कहाँ पे है? Root node is located between left and right. So left में कितने nodes है वो मुझे पता नहीं. Maybe there is one, maybe there are three, maybe right side we have so many. So we don't know how many on left and right. But there is one root node in between the left and right over here, which is very difficult to find out. But if you look at the post order sequence, it will have all the nodes which are coming at the left side, followed by all the nodes which are coming at the right side, and at the last we will have the root node. So looking at this particular notation, I can say the last node in the post-order traversal is the root node of the tree. So if I easily find out who is the root node, then my job is easy. Okay, so once if I find the root node is A, then I can say, okay, A is the root node, I can draw my tree with that, and then I can say, if A is a root node, I will just mark A in the upper sequence also, that is in Inorder Traversal, and Inorder Traversal is LVR. So V I have found my root. So now it is very easy for me to say who is on left and who is on right. So I can say this particular part is on left and this particular part is on right. It is very easy for me to say, because here I cannot say who is left and who is right. So then I can say, okay, D, B, H, E, I. So first 5, then F, J, C, G, okay. Then these are left and these are right. Okay, so now I can say who all are on my left and who are all on my right. This is followed, everyone. So I have just copied this particular line over here and this particular line as a right child of the tree. Now I have to go ahead and solve each of them one by one. So first of all, let me solve this left block. So I will just focus on this 5 words in this Inorder and Postorder Traversal sequence, that is D, B, H, E, I. So what I will do, D, B, H, E, I have highlighted with the color. Okay, so I'm just ignoring this part. Now in this first 5 letters, again I have post order means L or V. So the last one will tell me the root. So here last one is B. So I have marked B over here also. Okay, now what I will do is, whoever is on the left of B is a left child and right of B is a right child. So I can easily say D is on left and HEI is on right. Okay, now with this I have solved it one by one, step by step. So step by step only we can go ahead and keep solving this tree. So when you're writing this in your book, see to it you write down all the steps one by one. Directly don't draw the tree. Yeah, you have to show all the diagrams which I'm showing as the steps. So now I'm moving ahead. Now the next task for me is to find out this HEI or solve the HEI. So I will just take only HEI in interest. Okay. So now only HEI I have highlighted. So with the first post-order traversal technique, okay, I can say L or V, that means E is the root node and H and I में से कोई तो एक left right है. I don't know who is left, who is right. So if I take E in the in-order sequence, I can say okay, it is in-order is L, V, R. So E के left में जो है वो left child है, E के right में जो है वो right child है. So I can now say who is at the left of E, that is H, and who is at the right of E, that is I. Okay, so now I got this particular side of the tree solved properly. Now we'll just go to the next part, that is F, J, C, G, and try to solve it. If you see here, F, J, C, G is like this, and here F, J, C, G is like this. So again, if I want to find out the root of F, J, C, G, can you tell me what is it? Okay, so your guess is right, that is post-order traversal will give us the last node as the root, and now I can say C is the last over here, so C is the root. Okay, so C will come as a root and C ke left and right will be my left right over here. So as we go ahead, C I have highlighted with the blue color, that is the root which I found. Then left of C is this and right of C is this. So with this I can solve and I can say that the left of C is here and right of C is G. Now what we have over here is we have only one value remaining to solve, and that is Fj. So I will just concentrate on node Fj. So here in Fj, the F is last. That means F should be root. And J left child है कि right child है वो मुझे in order में पता चलेगा. So in order में F के बाद J आ रहा है. That means he is the right child. And that's why I will make J as a right child of F. So with this we are done with the tree. All the nodes are solved and my final tree is ready. If you just find out, if you are confused whether my answer is correct or not, so simply take this tree, try to find out the Inorder traversal. If it is matching to this particular traversal given by them, okay, then you can say, okay, my answer is correct. You can find out the post order also and just cross check whether your answer is correct or not. Okay, so this is all about another type of a question, how the different traversal techniques are given to us and we have to find out what is the binary tree for this traversal. Now there is a small activity I have given for you, that is I have given you a question, construct the binary tree for the Inorder and Preorder traversal sequence given below. यहाँ पे हम लोगों ने इनऑर्डर और प्रीऑर्डर ट्रैवर्सल सीक्वेंस यूज किया है. सो व्हाट यू हैव टू डू इज लुकिंग एट दिस टू पर्टिकुलर क्वेश्चंस, आपको यू हैव टू आइडेंटिफाई द आंसर. Okay, and that answer you have to generate. Okay, and you have to solve the same way as I have done, and once you get the answer, once you get the tree for this in order and pre-order, you have to find out which post-order sequence of the same tree and give that as the answer. Okay, you can give your answer in the comment box below. So thank you everyone for watching this video. I hope you understood this topic. Okay, if any queries, any doubts you have, you can anytime ask me in the comment box below. Thank you everyone. Bye bye.